Welcome to my 58th tutoring session in A-level chemistry. In this video, I'll talk about spectroscopy. What is spectroscopy? Spectroscopy is a scientific study which involves the interaction of electromagnetic radiation of various wavelengths with matter. Now, when the radiation strikes the matter, the radiation can be absorbed, emitted, or scattered. And it depends on the specific type of spectroscopy that is being used. Now, the outcome of this interaction between the electromagnetic radiation and the matter is the spectra. Now, the resulting spectra can be obtained using an instrument called spectrometer or spectrophotometer. Now, the spectra that is obtained using this instrument is a plot of absorbance on the y-axis, that is the amount of radiation absorbed by the drug molecule, versus the wavelength on the x-axis, the wavelength used for the particular spectroscopic study. And what kind of information can you get from this spectra? Now you can get a detailed information about the structure of the molecule from the absorption spectra. Now the matter can be an atom, it can be a molecule, or it can be even an ionic substance like potassium permanganate or potassium dichromate. Now there are two possible outcomes or possibilities when the electromagnetic radiation interacts with matter, or when the radiation strikes the matter. The first possibility is that the radiation can be absorbed by the drug molecule. The second possibility is that the radiation, when it strikes the matter, it will be absorbed, and later on the absorbed radiation will be released or emitted. Let's say I is the intensity of the incident radiation, IA is the intensity of the absorbed radiation, and IE is the intensity of the emitted radiation. Now in case of absorption spectroscopy, what you are trying to do? We are trying to measure the amount of radiation absorbed by the drug molecule. So in absorption spectroscopy, the absorption of radiation is being studied. While in case of emission spectroscopy, emission of radiation is studied. That is, we are trying to measure the amount of radiation emitted by the drug molecule in emission spectroscopy. And we all know that light is a sinusoidal electromagnetic wave. An electromagnetic wave is made up of two components. One is the electric field component, and the other is the magnetic field component. And these two components are mutually perpendicular to each other. That is, both electric fields and magnetic fields are oriented at right angles to each other. When the radiation strikes the molecule in the ground state, it absorbs the radiation and undergoes transition to the excited state. Now this process of transition of the molecule from the ground state to the excited state is called excitation. So when the radiation strikes the molecule, the drug molecule absorbs the radiation, it undergoes transition from the ground state to the excited state. Now the ground state is highly stable in nature because it has least energy, while the excited state is highly unstable in nature as it has excess of energy. Now the drug molecule in the excited state, it has excess energy, it is highly unstable in nature. It tends to come back to the ground state. And how does the molecule do that? The molecule, it releases the excess energy that it has absorbed from the radiation, and gets back to the stable ground state. And this process of transition from the excited state to the ground state is called relaxation. And during relaxation process, the molecule in the excited state, it has excess energy and it releases the excess energy and gets back to the ground state. And the process is called relaxation process. Now spectroscopy is of two types. One is the absorption spectroscopy and the other is the emission spectroscopy. In case of absorption spectroscopy, we try and measure the amount of radiation absorbed by the drug molecule. That is, we are trying to measure the component IA, that is intensity of radiation that is absorbed by the drug molecule. Well, in case of emission spectroscopy, we are trying to measure the amount of radiation emitted by the drug molecule. That is, we are trying to measure the IE component, that is the intensity of the emitted radiation by the drug molecule. Now, under absorption spectroscopy, we have UV visible spectroscopy, infrared spectroscopy, atomic absorption spectroscopy, and NMR spectroscopy. Now, when the intensity of electromagnetic radiation strikes the matter, the drug molecule absorbs the radiation. Now, the question arises, which component of the electromagnetic radiation interacts with the matter? As electromagnetic radiation is a sinusoidal wave, it is made up of two components. One is the electric field component and the other is the magnetic field component. Now, these two components are mutually perpendicular to each other. That is, the electric field component and the magnetic field component are oriented at right angles to each other. So, when the radiation strikes the matter, so one of the component interacts with the matter. Now, in case of UV visible spectroscopy, infrared spectroscopy, and atomic absorption spectroscopy, it is the electric field component of the electromagnetic radiation that interacts with the matter. While in case of NMR spectroscopy, it is the magnetic field component that interacts with the matter. So that's about the absorption spectroscopy. What about the emission spectroscopy? Now, in case of emission spectroscopy, when the intensity of electromagnetic radiation strikes the matter, certain amount of radiation is absorbed, and later on the absorbed radiation is released in the form of radiation. That is, certain amount of energy is being emitted in case of emission spectroscopy. So in case of absorption spectroscopy, we try and measure the amount of radiation absorbed by the drug molecule, while in case of emission spectroscopy, we try and measure the amount of radiation emitted by the drug molecule. So we have a molecule in the ground state. Now the molecule in the ground state is always stable as it has least energy. When radiation of intensity I, when it strikes the molecule in the ground state, it undergoes transition from the ground state to the excited state. Now this transition from the ground state to the excited state is called excitation process. And let's say IA is the intensity of radiation absorbed by the drug molecule. And the excited state is always unstable in nature as it has excess energy. And where does this excess energy come from? This excess energy comes from the radiation. So in absorption spectroscopy, absorption of radiation is measured or studied. So this is about the theoretical concept. So what about the experimental aspect? Now, how do you measure this amount of radiation absorbed by the drug molecule? We make use of the instrument called spectrophotometer. So by utilizing this particular instrument, one can measure the amount of radiation absorbed by the drug molecule. When radiation of intensity I, when it interacts with the drug molecules or the sample taken in the sample cell, that is the cuvette, certain amount of radiation is being absorbed. So let's say IA is the intensity of radiation absorbed by the drug molecules. Now certain amount of radiation is absorbed by the drug molecule, that is IA, while certain amount of radiation is being transmitted and absorbed, that is IT. So IA is the intensity of radiation absorbed by the drug molecules, while IT is the intensity of the transmitted light that is transmitted, that passes through the sample cell and absorbed. And it is this transmitted radiation which is not absorbed by the drug molecules that falls on the detector. A signal is generated which is amplified and recorded. Now what is the function or role of the detector in the instrument? Now the function or role of a detector is to convert the light energy into electrical signal. Remember, it is the light energy that is interacting with the detector, that is IT. So IT is the intensity of the transmitted light that is falling on the detector. So it is the light energy that is falling on the detector. And what does the detector do? The detector converts the light energy into electrical energy, and a signal is generated which is amplified and finally recorded in the form of absorption spectrum. So absorption spectrum is a plot of absorbance versus wavelength. So intensity of incident light is sum of the intensity of absorbed light and intensity of transmitted light. So how do you get the intensity of the absorbed light? When you subtract the intensity of transmitted light from the intensity of incident light, you get the intensity of absorbed light. So how do you get IA value? So it is the instrument which does the calculation. So one can measure the amount of radiation absorbed by the drug molecule, that is IA, by using the instrument called spectrophotometer. So spectrophotometer instrument measures the amount of radiation absorbed by the drug molecule. So under absorption spectroscopy, you have got atomic absorption spectroscopy, UV visible spectroscopy, IR spectroscopy, and NMR spectroscopy. So that is about the absorption spectroscopy. Now moving on to the emission spectroscopy. When the radiation strikes the drug molecule in the ground state, certain amount of radiation is being absorbed. It undergoes transition from the ground state to the excited state. And excited state, as I told you, is highly unstable in nature because it has excess energy, and it tends to get back to the ground state. And how does it get back to the ground state? By releasing the excess energy that has absorbed from the radiation. And this process is called relaxation. And during relaxation process, the excess energy absorbed by the drug molecule is released in the form of radiation. So it is this emitter radiation, that is IE, that we study. So the emitter radiation is being studied during emission spectroscopy. So in emission spectroscopy, emission of radiation is being measured or studied. Now coming to the experimental aspect, when the intensity of radiation I strikes the drug molecules taken in the sample cell or cuvette, certain amount of radiation is being absorbed, that is IA, and later on this absorbed radiation is being released or emitted. And this emitted radiation by the drug molecule, that is IE, falls on the detector, and finally you get the emission spectrum. So emission spectroscopy, two types. One is flame emission spectroscopy, other is the fluorimetry. So a spectrum is a plot of radiation absorbed by the drug molecule versus wavelength or frequency of the light. So you consider the absorbance parameter on the y-axis. You consider the wavelength or frequency on the x-axis. And thereby you get the absorption spectrum. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.